Alrighty, we're in Unit 2. We finally made it. So, Unit 2 is the start of what's really algebra. We're going to be laying the foundations for ideas we're going to be seeing throughout the entire rest of the year, and this stuff is really what algebra is. It's all about functions, which are basically a little kind of machine. And while they're really straightforward, there's a lot of language and ideas and symbols and vocabulary that makes it more difficult. So, we're going to be moving at a little bit faster of a pace now. Make sure you're taking your time with this stuff, pausing when you have questions, asking us if you need to know something. And make sure you're taking your time to do all of the practice and using your notes on the formatives. Because that's the kind of thing that's going to give you A's in this class, and I want to see everyone succeed. So, let's start with notes 1. There's really two ideas in these notes, touching on variable replacement, which is the how of functions, and functions themselves, which is the why. Variable replacement's super straightforward, but we got to know it. It's like doing PEMDAS with an extra step first. The first thing we have to do is just replace the variable with a number before we simplify. The one thing I want to make sure you know, though, is when you replace a variable with a number, to put parentheses around that number. This is to make our work nice and clean, and to make sure we know what is our number and what is our variable. So, let's try them out here. We're going to simplify like we've done before, but when we have something like x, we're going to replace it with 3, because that's what the question tells us. So I'm going to write 2, parentheses 3. We simplify that, we get 6. I'm going to do the same thing here. X becomes 3, y becomes 5. Parentheses 3 plus parentheses 5. Now these parentheses aren't really doing anything because there's no operations inside of these. There's nothing to do inside these parentheses, so we just move on to the next part of PEMDAS. We're going to add and get 8. Instead, what these parentheses do is show that this number was a variable, that this was put in for x. Anyway, here I replaced x with 3, and there's nothing to do. It's already simplified. Here, I'm going to replace my x with 3, minus 2, do 15, minus 2, that's going to be 13. Notice that when I multiply, the parentheses go away, because we're no longer looking at whatever x became, we're looking at whatever it's simplified to. Here, replace x with 3, y with 5, and z with 6. I had 8. This variable is coming down, so we're going to leave it in parentheses, and then we're going to combine to get 14. Lastly, I end up doing 3, parentheses 3, minus 2, parentheses 5. Now in this case, we're going to follow PEMDAS. Make sure you do that. Multiplication first, I'm going to do both at the same time. So I have 3 times 3 is 9, minus 10 times 5, 2 times 5 is going to be 10. I end up with negative 1. Okay. So, variable replacement is just doing PEMDAS, but make sure you put your variables in first. When you replace your variable with a number, put in parentheses. Let's move on down. So, variables were the how, functions are the why. Functions are what we're going to be seeing for the rest of the school year. They're the heart of what algebra is, and they're a little framework, a little machine that does math for us once we know all the steps. Ultimately, they're an easy idea with a bunch of stuff that makes it look difficult. Functions are basically just machines. You put in a number, and it spits out an answer. The inside of the machine, the bolts and gears, are the variable expressions we did above. This is that f of x stuff you've seen before. And this language is going to be basically a constant for the rest of the school year. The parts of this machine are pretty straightforward. This f, for the f of x, is going to be the name of a function. We named this function f. F is the basic name we use because it stands for function. X is our variable, and specifically it's going to be the number we plug in to the expression. So it's going to be our input. We plug it in, so it's our input. 2x, this is the meat inside. These are the bolts and gears inside of the function. That's going to be our expression. Whatever we plug in for x is going to be plugged into that expression as well. So I'm going to plug 4 in to my function. Since 4 replaced this x here, I'm also going to replace x here with 4. Okay? Then I simplify. This turns into 8. And I say f of 4, I keep the f of 4, equals 8. 8 in this case is the output. So it's coming out of the function. We plug in an x, we got out 8. We can have all different kinds of functions. Sometimes we have generic functions, but also we often have specific functions that represent specific things. We're starting with something basic though. A function can really be anything. It's really just an expression with a name. If g of a equals 10a, we can plug anything we want in for a. So let's start with 3. If I plug in 3 for a, I do 10 times 3, and that gives me 30. When a is 3, I plug it into g of a, I get 30. Same thing here. When I plug in 5, g of 5, I do 5 times 10, it gives me 50. I'm plugging in 3, 5, and then I plug 20 in for a, and I get 200. Ultimately, what's happening is the number inside these parentheses, it's what's getting plugged in for each of that variable with the same name. You'll see over here too. Miles per hour. We can use a function to show the distance we travel after any number of hours. If we're going 60 miles per hour, we have a function that says miles is based on an input of hours. So if we drive for 10 hours, we're going to plug 10 hours into our function. And it wants us to multiply by 60. 10 times 60 will be 600 miles. The beauty of functions too is that once we have the setup in place, we have 60 times hours, I can plug in any number of hours, even answers I don't know off the top of my head. So if I want to plug in 17 hours, I can use my handy little calculator and do 60 times 17, because that's what the function tells me to do. That's going to give me a total of 1,020 miles. I'm going to put my little miles symbol here. And what that's ultimately going to say is that when I drive 10 hours, I'm driving 600 miles. When I'm driving 17 hours, I'm getting 1,020 miles. When I drive 92 hours, I'm going to do 60 times 92. I get a total of 5,520 miles. You plug in hours, you get miles. What this is doing is it's creating a system where we can figure out how many miles we go for a given number of hours. Here's something similar. We can use another function to show how much money we make after any number of hours. So, let's say we make $12 an hour. If I work 1 hour, I plug 1 in for 12. And that gives me 12 hours, $12. Here, if I work 5 hours, I plug that in for hours. I do 5 times 12, and I make $60. Lastly, another weird number, if I work 397 hours, almost 400 hours, I can plug that in to my function, do 12 times 397, and I make a total of 4,764. What I did, I took a number of hours, I plugged it into my function. This is my input, and it gave me an output of 4,764. So, here's what a function is. It's an expression. It's like something up here. And it's a machine where it takes an input, plugs it into that function as x. Then whatever it simplifies to is my output. Variable replacement is the how. Functions are the why. Okay, so why do we do this? The why is pretty straightforward. Functions allow us to turn expressions into repeatable machines. Once we have the framework in place, we can plug anything we want into a function. 1, 2, 3, 4, it goes on forever. It also makes math problems repeatable. And lastly, it allows us to do math problems very fast. Once we have a function in place, we can plug things in super quickly. Instead of having to rewrite all the steps a million times, the only thing you have to do each time for a function is just plug in x and get an answer. We can get a lot of different values for hours, how many miles we drive, and how much money we make after a certain number of hours in seconds. It's faster than doing all the work by hand. Okay, let's go ahead and flip this over, and we'll take a look at the checking understanding. This has 3 parts. I'd like you to do some variable replacement. I'd like you to rename all the parts of functions. And then I'd like you to evaluate a lot of functions. For this one, you're going to plug in a bunch of different values into this function. And here, you're only going to plug a couple in, but I want you to show all the steps of PEMDAS as you simplify both times. Ultimately, we're just simplifying expressions again. And whatever it simplifies down to is the output of your function. Anyway, I'm going to give you time to work on that, and then let me know if you have any questions. Like I said, this stuff is trickier than the stuff in Unit 1. Go slowly with it and ask questions when you need to. Thank you very much, and I'll see you in the next one.